Hi guys, this is your 1.4 notes. Before I actually start on 1.4 notes, I actually want you to flip the page back to 1.3 real quick and go to the back question number 3 because I made a mistake. And one of my students, one of you all, pointed this out, so I appreciate that. So M is actually a midpoint. So I labeled this, but these two things are equal. So to solve for X and to solve for the length of AB, what you do is you actually set those two things equal. So that's what I did right here. So I set them equal to one another. You get your variables, your like terms to the same side. So I subtract x squared from here to move it over here, but it cancels it there. So I'm left with x plus 20 equals 5x minus 4. I subtract x from both sides, and I get 20 equals 4x minus 4. I add 4 to both sides to start getting that x by itself. And then I get 24 equals 4x. I divide by 4 on both sides, so I get x equals 6. But they wanted us to solve for the length of AB, so we're not done. So now I plug 6 in for A to M. So I do 6 squared, which is 36, plus 6 plus 20. That gives me 62. If M is the midpoint of this entire segment, that means whatever A to M is, M to B also will be that. So M to B is 62. So then I just combine those two, and I get 124 for the length of A to B. Okay, so I apologize about that. That was completely my fault. Okay, now going on to 1.4. So we are going to start talking about angles in this section. So we've been talking a lot about segments, right? So now we're going to get into angles. So an angle is two rays or segment that share a common endpoint. We call that endpoint their vertex. A couple of ways that we can name angles. So let's say we're talking about this angle. I would call this angle, you go around in a circle, essentially. Start at one of the rays, one of the ends of the rays, and you go around in a circle. So I could call that angle CAB. Or I can go the opposite way and call it BAC. What I cannot do is I cannot say angle ACB. Okay? This A is my vertex, so A has to show up in the middle. Your vertex is always in the middle when you're naming angles. Another way I could name this, if there's only one angle here. So what I mean by that is, let's say I have this angle. How many angles do I really have? Here I had one angle, but here I actually have three. I have one here, I have one here, and then I have the big angle. So at this vertex, there's actually three angles. But at this vertex, there's only one angle. If there's only one angle at the vertex, you can call it by its vertex. So I can call that angle A. A fourth way I could call this, let's say that there is a number inside here. Maybe they call it number 1. That is called angle 1. Okay? So there's a couple different ways that I can name that guy. It always has the angle symbol in front of it. Protractor postulate is just saying that any angle will match up with a certain amount of degrees on a protractor. Okay? Then we have different types of angles. So we have an acute angle. An acute angle is an angle whose measure is greater than 0 degrees, but less than 90 degrees. We have an obtuse angle, is an angle whose measure is greater than 90 degrees, but less than 180. If I'm going back to acute angle, that means the angle is in between 0 and 90 degrees. Same thing here. This angle is in between 90 and 180 degrees. So I can name it with inequalities. Not name it, but I can explain it with inequalities. A right angle is an angle whose measure is equal to 90 degrees. So in this case, angle A, see its vertex is A, and there's only one angle at the vertex, is equal to 90 degrees. And then a straight angle is an angle whose measure is equal to 180 degrees. So it looks like a straight line. So angle A is equal to 180 degrees if it's a straight angle. What you'll see a lot of times is like a little circle up here. That's the degree symbol. Okay. All right. Given the diagram, classify each angle and state its measure. So J, K, H. So when we're naming these, it tells us how to find it. So it's telling me to start with J. So I'm going to start here, go to H, and go up to K. And I'm hoping you guys have used a protractor before. So this is this more than 90 or less than 90? And it is less than 90, so it is acute. And then the measure is equal to, so if it's less than 90, that should help us if you already decide that, because it's either the 55 or the 125. Well, 125 doesn't make sense, right? So it has to be the 55 degrees. Go ahead and pause me and try B, C, and D on your own, and then unpause me whenever you are done so we can go over this. All right, the next one, you guys can see yellow or not, I don't know. G to H to K. So G to H to K, this angle here, that angle there is more than 90, so it would be obtuse. You guys see that? Oh, kind of. Okay. So that means that it's not going to be the 55, but the 125. I can't see it that well. Maybe hurting your eyes. Sorry, guys. Okay. L to H to K. Oh, okay. So this one, L to H to K. This is at 90 degrees, this line. And this is at 55 degrees. So if I'm looking at this angle, it's small, so it is less than 90, so it is acute. So to find that angle, I'm just going to subtract those two. So 90 minus 55, so 90 minus 50 is 40. 40 minus 5 would be 35 degrees. Okay, G to H to J. So I'm going G to H to J. So that's all the way across. So it is this guy. So that's not acute. That's not obtuse. It's not a right, but it is a straight angle. And the measure is equal to 180 degrees. All right, next page. All right, congruent angles. Two angles are congruent if they have the same measure. So like, let's say that this, we're going to do this. This is how we show that angles are congruent, or the same measurement. We put little arcs in them. So like on segments, to show segments are the same length, we put that little tick mark. Here we put little arcs in them, and it's the same arc, okay? So I would say angle, S-U-T, is congruent, there's my congruent symbol, to angle, N-M-O. Angle congruence is marked through the use of an arc. And then if we're talking about it in an equation, we use the congruent symbol. Angle bisector is a segment, ray, or line that cuts an angle in half. So it's like a segment bisector. Remember, a segment bisector cut the segment in half. An angle bisector will cut the angle in half. So if this is 70 degrees, then that means this is 70 degrees if ray, BD, is an angle bisector. Okay? Postulate 4, angle addition postulate. All that's saying is angle 1, we'll call that angle 1, plus angle 2 equals the big angle. So angle 1 plus angle 2, your two smaller angles, will equal the big angle. In this case, go around in a circle. It's equal to angle K to J to L. Okay? I want you to pause me, and I want you to try these two problems on your own. It's a lot of algebra, so I think that you guys are fine without me going over one first. And then once you're done, go ahead and unpause me so you can see if you got it correct. Okay, given that the measure of QST, so this big angle, is 135 degrees. Find Q to S to R, this guy. It's not saying that these two things are, that SR is an angle angle bisector, so I can't say that this is equal to this. But I do know that this plus this equals this, so that's what I'm going to set up. That 3x plus 1 plus 2x minus 6 equals 135. Combine like terms, same side, so 3x's and 2x's makes 5x's. 1 and negative 6 makes negative 5. That equals negative 1, or positive 135. Add 5 to both sides, so 5x equals 140. Divide by 5, so x equals, that goes in there, 28 degrees. That is not what it wanted me to solve. What it wanted me to solve is, it wanted actually to find the measure of, M equals, of angle QSR, so Q to SR, so this guy. So now I'm going to take that 28, I'm going to plug it in. 8, 16, 24, and 60 is 84. I hope I'm doing the math right. Should probably check it on a calculator since this is being recorded. Yep, 84 plus 1 is 85 degrees. Okay? Here, given that BD bisects angle ABC, find the measure of A to B to C. Okay, before we can find the measure of A to B to C, we're going to have to find X. This bisects it, which means that this angle is congruent to this angle, so I'll put the little arcs in. That also means that 5x minus 11 equals 4x plus 1. I'm going to do opposite operations to get x by itself, so I subtract 4x from both sides and I get x. I add 11 to both sides, so I get x equals 12. Once I find that, I'm going to plug it back in. Does not matter which one I do, so I'm going to plug it into this guy. So I'm going to do 4 times 12 plus 1. 4 times 12 is 48. 48 plus 1 is 49 degrees. So if this is 49 degrees and this is 49, I know that this is 49 because this is a bisector, so this angle equals this angle. Then that means that the measure of angle A to B to C is 49 plus 49, which is 98 degrees. Kind of like a band, a long time ago. Okay, that is all of the notes for 1.4. Those are the only notes that you guys have this week. So please make sure that you're getting all your work done and that you are preparing for that quiz this week. All right, I'll talk to you guys later. Bye.